Hi, Gabby! It's 2014, it's a brand new year, and we're going to have another science experiment! Hi there! So, once again, I'm Patrick. This is Gabby. And we're going to have another science experiment for this year.
Starring my Master Chief.
Master Chief, who's that? Yung boyfriend ni Maya. Alright. So it's 2014, and it's time for another science experiment. Because it's required for
Science STEM.
Science 6 STEM at home. Balloon powered car model. Alright. So, if we're going to have a car model, we need to show you the said item first, the said car, this balloon powered car model. Alright, let's get started. Oh!
And that's Master Chief from Halo.
Oh, it's Master Chief is guarding the car model. Let's look at the actual car, alright? Let's go, Master Chief! So this is the balloon-powered car. Alright? It is made out of recycled materials. Isn't that right, Gabby?
That was right.
Alright. Now, within this car, there are actually 3 samples of simple machines. And Gabby will help me describe these machines. So what would be this one?
That's the wheel and axle. That's the wheel and axle.
The wheel and axle. So this would be the wheel. This would be the axle. You can see the wheels are actually bottle caps from soda pop, or I can't mention the name of the brand of the soda pop.
Drinks.
The carbonated drink. And then the axle is contained. Can't see that. In the casing of ballpoint pens. Alright? Now, what simple machine is this? The one in front of this balloon-powered car.
It's a wedge.
Right. So you don't have to read that. So yeah, don't read it. Now, what's the other, or the third simple machine in this particular balloon-powered car?
Screws.
Screws! So why did we put screws here? Basically to stabilize this. This is a straw, alright? It's not a used straw because that would be unhygienic. Kids, don't use other people's straws. That's bad. Isn't that right, Master Chief? That's right! Alright. So basically, this particular vehicle is a jet-propelled machine. It's a jet propulsion machine. Air will be pumped through into this long balloon, this 9-inch balloon, a long 9-inch balloon, and then air will be pushed back out here. Alright? That will create some kind of jet engine, rocket propulsion, and it'll be awesome. Now, before we proceed, I'll just put this on record first. We are using this. This is a 9-inch long balloon. Now, I for one is of the opinion that this rounder balloon would be a better sort of propulsion mechanism. Why? Because once the air is out of this balloon, this will create drag. And it will actually slow down the said balloon-powered car. Alright. We will have 3 tries to put this balloon-powered car on the floor and see how far it goes. Gabby, will you please do the honors of taking away the chair?
Too heavy.
Is it?
Yes, it is.
Alrighty then. It's still in the frame. See? Like magic. Magic. Alright. Let's go to the floor. Say hi, Gabby.
Hi.
Hi.
Hi, internets.
Alright, internets. Let's do this. Gabby will now prepare her recording materials, basically a piece of paper and a pen. And I have this what do you call this?
Pumper.
An air pumper, because we like to pump.
Air.
Air. We like to pump air.
Or water.
That's correct. Alright. Let's proceed. Attempt number 1. Pump it. Let's see how far this goes. Gabby, could you please measure it? So if this is a starting point, that is how far in centimeters? About, what does it say? Could you please say it in the camera?
128.
128 centimeters. That would be our first attempt. Could you please record the same? We're recording now! Oh my gosh, it's so hot. You can't turn on the electric fan because you might probably not hear me. Alright? Attempt number 2. Carmi. Alright, Gabby, over here. Don't block the camera so people can see the car. Here. Alright? This is attempt number 2. Woo! It's pumping. Just pumped that sucker. Ugh. And release. Oh, that actually got farther. Let's measure it. So how far did it go now?
It's 138.
138. You got that, internet? Alright. 138. Now for our third and last try. Let's have the car, Gabby.
I hit my finger.
You hit your finger? As Master Chief would say, just endure the pain. This is the third and last try. Let's go. Measure it, Gabby. Now the distance for the third attempt clocks in at about
141 centimeters.
141 centimeters. Alright, internet, did you get that? Alright. Now let's discuss some matters, alright? Have a seat, Gabby. Say hi to your camera.
Hi.
So basically, this is our, excuse me. Much better. Oh my god, it's the new year and we're already sweating. So basically, this is our balloon-powered car. And I must say that it actually works pretty well, doesn't it?
Yeah, it does.
Unfortunately, this one, this long balloon, keeps getting in the way of the wheels because it's too long. To be perfectly honest, it would be much better to use a round balloon, which is shorter, so that it wouldn't create drag on the floor. Because the drag creates friction, and the friction actually interferes with the momentum of said car. That's physics for you. Physics. It's science. It's still science, all right. We're learning stuff.
We're only middle school, by the way. We don't have physics.
Yes, but you still watch The Walking Dead, and that's for adults. All right.
But it's fun. Yeah.
Some questions. So, in our first attempt, the distance covered by the balloon-powered car was 128 centimeters in length. That was the first attempt. In the second attempt, it was 138 centimeters. And in the last attempt, it was 141 centimeters. So what changed? Why did it get farther and farther?
Maybe because there was more air.
Correct! Because I pumped more air. More air means more power, more propulsion. That's why the car got farther. Alright? So, student, what have we learned?
That it is much better to use a rounded balloon because it won't create a drag.
Yes, no drag means no friction, and the thing will go farther.
Yeah.
How about me? Ask me a question. Student.
Stan Porter, what have you learned?
Well, for one thing, I learned that it's very good to recycle. This car was made from recycled materials like a piece of the cardboard backing that comes at the back of a piece of pad paper or a stack of pad paper, bottle caps, not a used straw, of course.
Don't do that.
Don't do that.
So unhygienic.
Unhygienic. And we use this potato snack canister for the body of the car, which the brand, I can't really say the brand of the same because that would...
Unless you saw it.
Unless the company pays me to do it. So alright,
Okay.
that would be our Science 6 STM at home experiment. Balloon powered car model. Alright. Some questions. What materials did you use? Like I said.
We said it already, so yeah. Sorry.
Bottle caps, casing for the ballpoint pen, from a ballpoint pen, straw, screws, a wedge, and straws. Or actually, straws for those, I can't say the word zesto, but zesto straws. Alright. And for simple machines, as we're going to reiterate, we had a wedge, wheel and axle, and screws. But to be perfectly frank, in order to make a balloon-powered car, we only needed a wheel and axle. There's really no need for the wedge or the screws. But they help. They really help because the wedge would help with braking the wind.
Actually, it can push if you have Lego bricks, because you don't organize your stuff, and then you're gonna play with it. Yeah, it's gonna push the Lego bricks away.
That's correct. And the screws, because
it supports the straw.
Supports the straw, so it wouldn't wiggle around. All right. So that pretty much does away with our Science 6 STM at home balloon powered car model experiment. This is a third quarter project for Miriam College. What's the section again?
Gandingan.
Gandingan. So yeah. Happy New Year, internets! Mahal kita, babes. Mahal na mahal kita.
YOLO! Sorry.